Bismillahirrahmanirrahim. Today we are going to talk about action potential. What is action potential? In this topic, I will discuss about the action potential, local potential, threshold, subthreshold stimulus, refractive period. Okay, as we know that our body consists of many thousand and million of the neuron. Suppose when I touch this area by the threshold stimulus. There are two types of stimulus: threshold stimulus, subthreshold stimulus. When I touch this area by threshold stimulus, by adequate strength, then this message is go to the brain and spinal cord with the help of a complicated process, with the help of a polarization and depolarization process. This process is called the action potential. So what is action potential? Action potential is an electrochemical changes, electrochemical fluctuation, and the cell membrane of the neuron and muscle cell. Okay, this is a message sending mechanism. This is a signal sending mechanism from the receptor to the brain and from the brain to the effector. Okay, so action potential is a signaling carrying mechanism. This is a electrochemical fluctuation and the cell membrane of the excitable tissue. What is mean by excitable tissue? Neuron and muscle cell is called excitable tissue because the cell membrane of the neuron cell and muscle cell have the ability to excite and carry impulse from one point to another point. Okay, so when I touch this area by required strength, by a threshold stimulus, then there produce action potential, and then action potential is go and the cell membrane along the cell membrane and the forward direction. Okay, this message go to this end to the synaptic terminal, and the neurotransmitter is released, and the same phenomena occur. Okay, so when I zoom this area, only this dendrite area, this is a very difficult topic, but I make very easy. Okay, this is the structure of the cell membrane. These are the lipid heads, these are the lipid tail, protein, different types of channel. Okay, as we know that in the resting state, resting mean unstimulated state. When I do not touch this area during this state, during this unstimulated resting state, inside of the neuron or negative charge, inside of the neuron, inside membrane is negative charge, while outside is all outside is positive charge. More negative charge about minus 70 millivolt, and about plus 70 millivolt, minus 70 millivolt and plus 70 millivolt. Why? This is because in the resting state or in the excited state, there are present our cell membrane. Each cell membrane of each cell have a specific types of pump which is called sodium potassium pump. This is the pump. This is the unique pump which pump two potassium inside and three sodium outside. This pump continuously around the clock all the time. Pump two potassium inside and three sodium outside. Okay, so the potassium and the sodium have same charge. Sodium and potassium have one positive charge, one positive charge. Okay, so the net charge there is the negative because suppose there go four potassium. Suppose there one cycle two potassium three sodium, two cycle four potassium six sodium. So there are four potassium, there are six sodium. So there are six positive charge. There are four positive charge. So this area become negative while this area become positive. Okay. Cell membrane also consists of chlorine channel as which as pump on site chlorine. So the N side become negative. So there are present additional channel which is called chlorine pump, which pump the chlorine N side. So the N side become negative. But there are also present a specific channel which is called potassium calcium channel, which pump calcium outside. So the outside area become more positive while inside is more negative. Okay, this is a resting state. This is a unstimulated state. Okay, but when I touch this area by adequate strength, what is mean by adequate strength? That strength or threshold stimulus, that stimulus which produce action potential and the cell membrane of the neuron or the muscle cell. Okay, that stimulus is called adequate strength or threshold stimulus. When I touch this area by adequate stimulus, then as you know that this is more negative area, this is more positive area. There present large number of potassium. As you know that cell is a bag of the potassium. There present large number of potassium than the sodium, and there present large number of sodium. Okay, so here the potential is minus 70. Here the potential is minus 70 millivolt. When I touch this area, then large number of sodium. When I touch this area, then large number of sodium, voltage regulated sodium and voltage regulated potassium channel are open. Large number of voltage regulated sodium and potassium channel are open. So sodium rush inwards, influx of sodium start. Large amount of sodium go out inward and large amount, and then after this phenomena, large number of potassium go outward. So when sodium influx start, the potential is piled down. It is reached minus 60, minus 50, minus 55, minus 10, 0, up to the plus 35. So the when sodium go inward, there the negative sodium are positive charge, so there the negativity is decreased from minus 70 up to the plus 35. Okay, after this phenomena, the potassium go outward, and there again the negativity increase. So the negativity increase. So sodium go inward, it decrease the negativity. Inside the negativity is decreased. So this phenomena is called depolarization. By the depolarization, the direction of the current is inward, because as you know that what is the direction of the current? The direction of the current is the direction of the ion, the direction of the positive ion, the direction of the negative ion, the direction of the electron, proton. So when sodium go inward, the direction is inward. When potassium go outward, the direction of the current is outward. So the current move in the forward direction in the palm of wave. So when the sodium go inward, this phenomenon is called depolarization, because it depolarizes the membrane. How this is a graphical representation. When we give threshold stimulus, sodium start go inward. Why? There is arise a question. Why sodium go inward and potassium go outward? Because this is the resting state, minus 70 millivolt per neuron. This is a neuron cell per neuron cell resting state. Resting membrane potential is minus 70. For the skeletal muscle, it is a minus 90. For the skeletal is minus 90, and for the neuron is minus 70. For the neuron, the threshold stimulus, the threshold potential is minus 55. Okay, so this is the resting state. What is local potential? Local potential is that potential. The action potential is go in the forward direction, while the local potential is not go in the forward direction. The action potential is produced with the help of the adequate strength. With the help of the adequate strength, while the local potential is produced with the help of the inadequate strength. So what is local potential? What is adequate strength? What is inadequate strength? Inadequate strength are the strength which bring only the local potential, which bring only the graded potential. When I touch this area, suppose when I touch this area, I do not feel this touch. So this is the graded potential. When I touch this area, then suppose this one. When I touch this area, then the depolarization is go about to the 65. So when I touch this area, small number of sodium go inward. By when I touch this area by a very low effect, by very low stimulus, small number of sodium go inward, and along with this, small number of potassium there are present. This is the mechanically operator channel. Suppose this is the mechanical channel for the sodium, and there are present also channel for the mechanically potassium channel. So when I touch this area by a small strength, small number of sodium go inward, and along with this small number of potassium go outward. So there the there the effect of the action potential is not produced. There this is the only graded potential. There the current is die out, the current is finished. When I touch this area by a small by by a large, then the suppose in the first state 5 sodium go inward, and the second state 10, 20, 30, 50. So the small number of sodium go inward, small number of potassium go outward, but there these are the sodium and these are the potassium which cannot produce action potential. But when I touch this area, when I touch this area to reach there, the action potential is reached, suppose from minus 70 up to the minus, this is the up to the minus 45, then action potential is not produced. But when I touch this area by adequate strength, then adequate strength to move the enough sodium inward in order to bring the depolarization up to this point. When I touch this area, uh, when I touch this area, and to bring the depolarization from minus 70 up to the minus 55, then at this point, at this depolarization point, the action potential is start. Okay, so when I touch this area, the to reach the depolarization up to minus 55, minus 55, minus 55, then suddenly these channels are open. These are the voltage regulated channels are open, and a large number of sodium go inward, and then large number of potassium go outward. So the action potential is produced here. Sodium potassium pump only pump sodium and potassium. These are the mechanically operator channel. Mechanically operator channel help and help and the production of uh, graded potential, but actually it does not produce action potential. Action potential is only produced due to this channel. This is the suppose sodium voltage regulated channel. This is suppose the potassium voltage regulated channel. Okay, so the deer produce graded potential, and with the help of the graded potential, uh, action potential is arise, but the action potential is produced by this channel. Okay, so this is the mechanically operated channel. These are the voltage regulated channel. So when sodium, large number of sodium go inward, large number, skip this one, skip this potassium channel, large number of sodium go inward, so the depolarization is fall from the minus 70 up to the 0 and up to the plus 35. How this phenomena occur? This is called the depolarization up to this point. This is the depolarization phenomena. So when the depolarization occur, the direction of the current is inward direction. Then after this repolarization occur, mean potassium go outward in order to obtain its own negativity on the side. So this is called repolarization. Depolarization and repolarization carry current in a forward direction. How depolarization occur? As you know that suppose here this is only sodium channel. only consider sodium voltage regulated channel. Why this is potassium voltage regulated channel? Skip this one. Sodium voltage regulator channel have two gates. One is called the action gate and the other is called the non-action gate. The action gate, the action gate is closed or completely closed in the resting state. This, this is the resting state. And the resting state, the action gate is completely closed while the non-action gate completely open. When I touch this area by adequate strength, by strong stimulus, then the action gate is going on opening and the non-action gate is going on closing. So at the 0 point, at 0, some gate are completely closed at 0 point, some are completely closed at 15, some at 20, some at 30, and some at the 35. Okay, so mean of the gate are closed at the 0.0 millivolt. Okay, so the action potential, the equilibrium, this is minus 55, this is minus 70, minus 70, minus 80. So the equilibrium is decreased along with the time. Okay, when the sodium go at the 0 point, the action gate completely open, but the non-action gate completely close at 0 point or at this point or at the 15 or 30 or 20. Okay, so this is called the depolarization. Here, this is the this one is this condition. Sodium go inward and then into the cytoplasm. Okay, so this is the depolarization state. But when it reaches to the 0 point, this get completely closed while this get completely open. So the incoming sodium is stored here and do not go to the cytoplasm of the exoplasm or cytoplasm of neuron. Okay, so this is the current inward direction. After this one, why? Here arises a question: why the depolarization is go from 0 up to 35? Because the equilibrium potential for the sodium is 65 plus 65. So what is equilibrium potential? Equilibrium potential is the tendency of the ion, of the positive ion or negative ion, to balance the charge on either side of the membrane. Because there is negative charge, there is positive charge, the sodium go and out inside. So this sodium want to obtain its 65 equilibrium potential. But unfortunately, at this point, at 35 or 0 or 15 or 20, the action gate is the non-action gate is closed and no more sodium go inward. So this is the main concept. Okay, when after this one, the potassium gate is going on opening. So the more potassium go outward. When more potassium go outward, this area going on negativity while this area going on positivity. So this is the depolarization, this is the repolarization. So when the potassium go outward, the repolarization start and obtain minus 70. This is the minus 70 millivolt. Instead of minus 70 millivolt, more of the potassium go outward. There are present additional channel through which additional potassium go outward. So instead of minus 70 millivolt, add obtain minus 85 millivolt. Why this phenomenon occur? Because the equilibrium potential for the potassium is minus 85 millivolt. So potassium want to obtain its one equilibrium potential. So the membrane become repolarized. Inside is negative while outside is positive. There is the depolarization, there is the repolarization. Okay, so the depolarization and the repolarization carry current in the forward direction. Okay, so this is the concept for the depolarization and the repolarization, which carry impulse in the forward direction. From 0 point up to this point, this is called overshoot because large number of sodium go inward. This is called overshoot. While this area from 85 to minus 70, this area is called undershoot because there occur the, this is over depolarization. This is the over depolarization. Why this is the over repolarization. This is the, here the repolarization, but there is the over repolarization. Okay. So this is all about the action potential. Another important concept. Another important concept. This is a very complicated topic and very confusable, and but the most important topic. Okay. When sodium go inward, large number of sodium go inward. Okay. Large number of sodium go inward. Okay. These are the sodium. This is potassium channel. Okay. Potassium go outward. Okay. So this is one way of the current. For the flow of current in the forward direction, this is the sodium which go to the next area and stimulate this area. When this area is stimulated, just like this one, when there sodium go inward by the mechanically operated channel, this this channel is stimulated and a large number of sodium go inward. So the sodium which is already go inward, this some of the sodium go to the next area and stimulate this area, and thus open the sodium voltage regulated channel. When sodium voltage regulated channel open, then large number of sodium go inward. When large number of sodium go inward, then potassium voltage regulated channel open itself. This is on, this channel is open by the help of the, by coming some stimulation, some stimulation from this area. So sodium voltage channel regulated channel is open by stimulation, but the potassium voltage regulated channel open itself. So the potassium go out. So this is another wave. So the current move in the forward direction, and then from this area some sodium go in the next area and stimulate this area, so sodium go inward. So the current move in the forward direction. Okay. Another most important point. Current impulse flow in the myelinated and the non-myelinated neuron. Suppose this is a simple exam. Suppose this one. Suppose sodium come, and so this is the myelinated exam. Suppose sodium go inside, sodium go inside, and potassium go outside. They produce a wave of the depolarization in the repolarization. But in the myelinated neuron, as you know that the impulse go in a quick way, because this sodium go from this area to this node of Renwer and stimulate this area, and here sodium go inward and potassium go outward, and from this area sodium go to the next area and stimulate this area. So there the current jump, there the current move in the jumping mechanism. Okay. So this is the as you know that the myelinated neuron is for the quick transport of the impulse. Okay. So there the current jump in the move in the jumping mechanism. But in the non myelinated neuron, continuously sodium go inward, potassium go outward, sodium inward. So this is the slow, carrying impulse, well this one is the fast impulse. They are in the jumping, because this area is covered by the Schwann cell, and the Schwann cell make this area impermeable for the inward of the potassium and outward of the inward of the sodium and outward of the potassium. Okay. So the main function of the Schwann cell is the myelination. Myelination is a give insulation. This is the importance of insulation which do not allow the permeation of the sodium and potassium. So the current move in the jumping mechanism, while in the non-malignant neuron current move continuously. So it is a slow mechanism, while this is a fast mechanism. Okay, so this is the main concept. Another important point is the threshold stimulus. As you know, threshold stimulus are those stimulus which bring action potential, while subthreshold stimulus are those stimulus which bring graded potential. Here, the graded potential. What is the difference between graded potential? The action potential move in the forward direction, while the graded potential do not move in the forward direction. This is the graded potential. These are the graded potential which do not move in the forward direction, while the action potential move in the forward direction. This is one difference. Another difference is the graded potential is can be added, while the action potential cannot be added. Okay, this is sorry, this is also called local potential. Local potential is added, while the action potential do not be added, because this is local potential, small local potential. This is someone is large, this is someone is another large, large and large and largest. So as you know that as you know that from my the previous lecture, the myelination, that graded potential, suppose it means that small stimulus produce small local potential, large action large stimulus produce large action large graded potential, and then with this one and this one. So these are added, but the action potential is not be added. When when once the depolarization reach up to -55, then the threshold is smaller or large or very large, the action potential is produced. When the when the threshold stimulus, suppose this is the diagrammatic pressure, when the threshold stimulus is suppose this one, then the action potential is produced. But suppose the threshold stimulus is this one, then same amount of the action potential is produced. But here the frequency is different, but the frequency is the same, but the amplitude is different. So the action potential is cannot be added, while the local potential are added. Okay, this have the same frequency. This how this have same frequency? Small action potential, large action potential, and the largest action potential, all are feel by our body, but it have different amplitude. Sorry, it have same frequency and have different amplitude. Okay, so this is the difference. Another point is the refractive period. What is mean by the refractive period? Refractive period is the period is the time during which the neuron do not produce impulse. Okay, what is the refractive period? Refractive period is the period during which the neuron or muscle cell do not produce the action potential. How this phenomena occur? As we know that when the depolarization is reached up to this point, then this gate is completely closed, while this gate is completely open. Okay, so at this point, when we give at this point at this time, when we give another stimulus to this area, then the another depolarization cannot go, then the neuron do not go under another depolarization at this point, because this gate is open, this gate is closed. This is the inactive state, but this is the active state. When the when with the passage of time, this gate is going and closing, while this gate is going and opening. But at the minus 75 minus 70 stage, but at the minus 70 stage, this gate is completely closed, while this gate is completely open. So this is the active state. So from this point, from the point from the point of 35 up to the point of 70, this is called the absolute refractive period. This is called absolute refractive period, because there uh, at this point, when we give a very large strength, very large strength to this area, very large stimulus to this area, it do not produce depolarization, because the action there, the non-action gate is closed, and the further sodium do not go further. There the there this gate is closed, while this gate is open, and the large and the further sodium do not go annual direction. But with the passage of the time, the this gate is come to its normal state. So from this point, during the repolarization, this from this point up to 70 minus 70 state, this is called absolute refractive period. But from this point, undershoot area is called relative refractive period. This is called relative refractive period. Why it is called relative refractive period? Okay. At the first stage, we decrease depolarization from 70 to minus 55, from minus 70 to minus 55. So it require someone least small amount of the threshold stimulus. But during for the second stimulus, we need to carry the depolarization from minus 85 up to the 55 by the next time. So this need strong stimulus. This need strong stimulus than this one, because this one require least threshold stimulus, but this one require someone large stimulus than this one. Okay, because there the distance is become more, while there is the distance is least. So during this stage, when we give stimulus from this point, so from this area up to this area, 70 area, up to 70 area, this area is called relative refractive period, because this is the extra area. So during this time, the neuron do not undergo the actual depolarization. Okay, so this is the refractive period. Okay.